Instead, they use everyday tools they find along the way, like ropes and pulleys. This is why the most widely used torture device of the Inquisition has a disarmingly simple design. They call it the strappado. The strappado harnesses the power of gravity to exploit a weakness of the human body, the shoulder joint. Inquisitors force the victim's hands behind his back and hook them into a rope running through a pulley suspended from the ceiling. Next, they tighten the rope, which lifts the accused into the air. The force of gravity takes over, constantly pulling down on the victim and taxing the shoulder joints. Eventually, the shoulders dislocate.
The engineering of the strappado is kind of diabolical in the fact that it uses the human's weight with gravity to ensure that it's going to dislocate his arms. The wheel acts like a gigantic lever arm, which allows you to turn the axle, lifting the person's weight with relative ease.
The strappado's target, the shoulder joint, is one of the most vulnerable parts of the human body.
And there were several things that the torturer could do. You could just be left hanging there, pretty much just incredible pain. Weights could be added to your feet, and if enough downward force was applied due to gravity, it could dislocate your shoulders. If they certainly wanted to dislocate your shoulders, all they had to do was raise the rope up a little bit and drop you from a height. Really just causing a ton of pain, but definitely not anything that was going to kill you.
Inquisitors in Italy, France, and Spain build variations of the strappado to extract information from accused heretics. Judges base the degree of torture on the severity of the charges. The strappado torture can be as simple as merely threatening the accused with the device, or as severe as weighting down the victim and jerking him to a dead stop during free fall. This would cause instant shoulder dislocations.
This could be a chronic problem for this person. They're going to chronically dislocate their shoulders, which is a very disabling and painful thing to have.
But can a strappado actually cause permanently crippling injuries? To answer this question, a replica of the machine undergoes a series of tests. First, a 40-pound dummy gets weighted down with an additional 30 pounds. A dynamometer will measure the amount of force the pulley hoist generates. The dummy's shoulders should give out at the same point human shoulders would dislocate.
Okay, Eric, you can start lifting him up with the strappado.
All right, here we go.
Medical studies indicate it takes 274 pounds of total force to instantly dislocate both shoulder joints.
So even with this extra weight, we might not get an immediate dislocation. So there's really only one way to get that instant and quick shoulder dislocation, and that's with the sudden drop.
Strappado, when used to drop a person to dislocate their shoulders, basically gains its energy from gravity through potential energy. The potential energy of the person being lifted up and then dropped through a certain distance is going to create kinetic energy, which will ultimately, when stopped quickly, increases the force on his shoulders.
This second test will determine the distance a victim must drop to dislocate both shoulders.
So now we're going to simulate a 1-foot drop.
Right.
A strappado drop requires a second operator to pull down on the rope while it's already locked off to an end height. The test begins with a 1-foot fall.
Okay, and we're at 70 right now.
Okay.
And let it drop.
All right, 3, 2, 1.
Okay, I got up to 120.
So dropping the weighted dummy 1 foot generates an additional 50 pounds of force. This would cause agonizing pain, but it's not enough to cause shoulder dislocations. For this next test, the second operator raises the dummy 2 feet above the end height.
2-foot drop
Okay.
should put us right around the 275, 325
Perfect.
foot-pounds.
God, that's not very far at all. All right.
Yep.
Okay.
Foot. 2 feet.
We're back at 70. It's hanging free. And let her go.
3, 2, 1.
I only got up to 90. So something probably happened with the dummy, which that would be why.
He
dislocated.
So a 2-foot drop dislocates both of the dummy's shoulder joints. But why does the dynamometer say the machine generates only 90 pounds of force? It should register a minimum of 274 pounds to dislocate both shoulders.
I only got up to 90, and we saw a total dislocation. So it must have passed about 274 pounds of force.
So it spiked.
Yeah.
It had to have spiked way up there, and then it came through.
And it just happened so quickly that the shoulders dislocated and the dynamometer didn't get a chance to register it.
To test whether the dynamometer missed the peak, the operators will adjust the device. The sensor will now register the greatest force generated during the test, regardless of how quickly it happens.
2, 1.
All right.
Okay.
So, according to this, before the shoulders dislocated, it had a peak of 145 pounds of force.
Once again, the Strapato dislocates both of the dummy's shoulders, but the readout is far below the force needed. There's only one explanation. The Strapato is far more efficient than anticipated.
Actually, that worked perfectly. That's exactly what we should have seen. The shoulders took all of the force, not the dynamometer.
That's actually 100% correct. When we did the test with the dynamometer, we were reading the inline stress of the rope. We weren't reading the actual pressure created by the lever arm that the human body makes. By hoisting up the victim with his hands behind his back, because his arms were out a distance from his body, he creates a lever arm. You need a lot less force to dislocate his shoulders in that position.
In effect, the victim becomes a piece of the machine. Tying the arms behind the back creates a lever mechanism, and this gives the Strapato a mechanical advantage. Ultimately, the lever arm made by human arms reduces the amount of force required to dislocate both shoulders.
So in comparison, if you put the victim's shoulders in line, it would take the full 137 pounds per shoulder to dislocate it, whereas if there's arms behind his back, you can do a lot less, do the same damage.
Although the Strapato is a simple pulley device, it's downright devious. The victim's own arms lend a hand to the machine, so it can generate disabling injuries. The Strapato is so potent, torturers still use it today in some parts of the world. But in the world of special effects, rope and pulley systems hoist and instantly stop stunt professionals on modern movie sets. During the Inquisition, interrogators persuade heretics to confess by inventing a host of diabolical machines. The most pointed proof of their perverse imaginations is a device from the Spanish Inquisition called the Judas Cradle.
The Judas Cradle is an example of human ingenuity going down a very dark path.
The Judas Cradle is a heavy wooden pyramid elevated on 4 legs like a stool. Suspended above the pyramid is a cradle system of several ropes and pulleys connected to the victim's torso and feet. Accused heretics hang stripped naked from this system over the pyramid. Torturers have several techniques for using this device. They can drop the victim onto the pyramid or slowly lower him onto the tip so he sits there for an extended period of time.
As gravity is acting upon the victim and pulling the victim down onto it, the pyramid acts as a spreader. We have 4 corners that are going to decrease the amount of friction and actually create almost a slicing motion to help spread the victim out, as the flat spots will act like a clamping device to keep the victim open.
The Judas Cradle's power lies in its ability to target some of the most vulnerable parts of the human body.
Torturers are very good at finding areas of your body which are particularly sensitive to injury. Obviously, the nether regions of your body are very sensitive, very vulnerable, full of nerve endings, and particularly sensitive to injury.
During the Spanish Inquisition, getting suspects to confess their own guilt is just the beginning. Interrogators leave victims on the Judas Cradle until they betray all of their co-conspirators. This is how the device gets its name.
The Judas cradle is named after Judas, who betrayed Jesus to the Roman authorities. It's an appropriate name because anyone who experienced this excruciating pain would give up any information about anyone or anything.
But which of the Judas cradle's torture techniques is the most efficient? The free fall or the controlled descent? A series of tests with a simulated human and a replica Judas cradle will determine this answer. Coming up, heretics quickly get the point of this stool of terror.